Let's continue with indefinite integrals. These are integrals without a lower and upper limit number to evaluate the antiderivative. We are just simply taking it one term at a time and finding the general antiderivative of the function. The antiderivative of sine x is negative cosine x. The antiderivative of cosine x is sine x, so we have a negative 3 sine x. There's no sign change when you take the antiderivative of cosine because the derivative of sine is exactly cosine, but there is a sign change when you're going backwards from sine because the derivative of cosine x is negative sine x. So if you're going in reverse from a positive sine x, you will have to account for that negative. Plus c for a constant of integration. The derivative of any constant is 0, so we need to make sure that we have that c for constant of integration when we are taking indefinite integrals. The second example, the antiderivative of secant squared theta is tangent theta. The coefficient 5 hangs on, so the antiderivative is 5 tangent theta. Minus 8 sine theta has an antiderivative of positive, notice the sign change, cosine theta plus c. The next example, the antiderivative for 3 sine x is negative 3 cosine x. E to the x has a derivative and antiderivative that stays the same. So as long as it's just simply e to the x, then your antiderivative will match. And the same thing for the derivative, it will match as well. Plus c for constant of integration. On the last example, well, let me double check, make sure it's the last one. No, it's not. So this top example, now that is an exponential term that does not have a base number of e. And yeah, I know it sounds silly to say that, but when you take the derivative of an exponential term that doesn't have e for a base, like this one is, I'm just going to use a for any number besides 0 or e, you will make a copy, and then you take natural log of that base. Well, when you go backwards and do an integral, isolating this a to the x term, you have to divide by natural log. Oops, I made a mistake there. That should be an a. So when you go backwards and you do an antiderivative, when you integrate just an exponential term with a base other than e, you're going to have to divide by the natural log of that base number. So long story short, the integral or antiderivative of a to the x dx is going to be a to the x over natural log of that base number. Now for our example, ours is 7 to the x, so let's take the first term, 4x. Its antiderivative is 2x squared. 4x squared over 2, simplify, that gives you 2x squared. The second term is the tricky one, minus 7 to the x. Replace your a's with a 7, so its antiderivative is going to be minus 7 to the x over ln, or natural log of 7. Be very careful there. Plus c for your constant of integration. So this part here is a little tricky on taking the antiderivative of an exponential term where the base is not e. The last example that we did in class, we had the integral of 3x minus 7 over x. Recall from Cal 1, that the integral of 1 over x dx is equal to natural log absolute value of x plus c. So I'm going to make a note of this. And then let's go back and look at the antiderivative. 3x has an antiderivative of 3x squared over 2. That doesn't simplify, so we're going to leave it 3 halves x squared. I went ahead and separated this second term and pulled the constant 7 out front. This is still minus the integral of 7 over x, but I pulled the constant out front, separated off the 1 over x dx just so that you could see that when isolated, that is ln of x. It's probably a good idea to put it in absolute value unless you're told the domain is positive. If you're told that it's positive, you can leave off the absolute value, but it never hurts to cover your bases. So our antiderivative, the indefinite integral, will be 3x squared over 2, or 3 halves x squared, minus 7 times the natural log of absolute value of x, plus your constant of integration. Let me know if you have any trouble. Swing by the office if you're on campus. Give me a call or shoot me an email, and I'll be happy to try and help you out.